Imagine sending a robot into a place so far, so dangerous, that even light from the sun takes nearly an hour to get there. A place of swirling storms larger than Earth itself, of crushing gravity, deadly radiation, and magnetic fields strong enough to rip atoms apart. Welcome to Jupiter, the guardian of Earth, the gas giant that shaped our solar system, and, as we recently discovered, a planet that holds far more mystery than we ever imagined. In today's episode of Mysterious Universe, we're not just telling the story of a space probe, we're telling the story of a silent observer that flew deeper into Jupiter's secrets than anyone ever had before. A robot called Juno. It was launched in 2011 with a single mission: figure out what Jupiter is really made of. But what Juno found wasn't just clouds and storms. It found impossible weather, mysterious energies, and a core that may rewrite how we understand planets. What if Jupiter isn't just a gas giant? What if, deep inside, it hides something more? Get ready. Because this isn't a documentary. This is a cosmic journey into the most powerful planet in our neighborhood, and a robotic mission that might have seen too much. Before we begin, make sure to subscribe, like, and turn on notifications for weekly deep dives into space, science, and the unknown. Now fasten your seatbelt. We're going to Jupiter. On a hot August day in 2011, a strange-looking spacecraft, triangular, covered in solar panels, blasted off from Cape Canaveral. It didn't carry astronauts. It didn't carry weapons or cameras designed for beauty shots. It carried a question. What's really inside Jupiter? Scientists had theories. Maybe it was just a thick soup of hydrogen and helium. Maybe there was a solid core. Maybe it was still forming from ancient solar dust. But no one really knew. Because Jupiter is deadly. The planet's magnetic field is 20,000 times stronger than Earth's. It generates radiation belts so intense, they can fry electronics in minutes. And there's no solid ground, just clouds, storms, and crushing pressures that increase with every mile you descend. So NASA sent a robot that could survive the impossible. Its name was Juno, named after the Roman goddess who could see through the clouds. And like its namesake, it was going to pierce the veil of Jupiter. But first, it had to get there. Juno didn't fly straight. It took a long route, swinging past Mars, then Earth, using gravity to slingshot its way to high speed. For 5 years, it coasted silently through the void, until finally, in July 2016, it arrived. And that's when the real mission began. The closer Juno got, the more Earth looked fragile. Jupiter wasn't just big, it was terrifying. Its famous Great Red Spot was churning like a hurricane the size of 3 Earths. Lightning storms flashed deep within its clouds, bolts 1,000 times more powerful than anything on Earth. Juno didn't flinch. It dropped into a polar orbit, circling from pole to pole every 53 days. Diving close to the cloud tops, just 3,000 miles above the atmosphere. From there, Juno started to see things we never expected. It turned its instruments to the North Pole, expecting calm clouds. Instead, it saw a giant storm surrounded by 8 smaller cyclones, perfectly arranged, all spinning like gears in a giant machine. Each storm was the size of a continent. How did they form? Why don't they drift? No one knows. At the South Pole, it found a similar pattern, but this time, the central storm had shrunk, hinting at dynamic weather patterns we still can't explain. But that wasn't the strangest part. Deep inside the atmosphere, Juno's instruments began to detect weird gravitational waves, ripples that didn't match any known weather. It was as if something massive was moving from below. What was under those clouds? For decades, scientists believed that beneath Jupiter's swirling clouds and chaotic atmosphere, there must exist a solid core, a dense heart made of rock and metal, formed in the early days of the solar system. But no one had ever seen it. No probe had gotten close enough. Until Juno. One of Juno's main objectives was to solve the mystery of Jupiter's core: how big it was, what it was made of, and whether it even existed at all. Using precise measurements of Jupiter's gravitational field, Juno began mapping the internal structure of the planet. As it orbited, the spacecraft's trajectory would subtly shift depending on the mass it passed over. By tracking those shifts with incredible accuracy, scientists could build a model of Jupiter's insides, like performing a sonogram on a planet. But what Juno found was not what anyone expected. Instead of a small, dense, well-defined core, Jupiter appeared to have a fuzzy core, a vast, diffuse region extending across nearly half the planet's radius. This core wasn't solid in the way we imagined. It was a swirling soup of heavy elements, rocks, metals, and exotic ices, mixed with hydrogen and helium. It was as if the core had melted, dissolving into the surrounding gas. This finding shook the foundations of planetary science. How could such a giant planet have such a diluted center? Had Jupiter always been this way? Or did something catastrophic happen in its past that disrupted its core structure? A bold new theory emerged. Perhaps Jupiter had experienced a planetary collision in its infancy. Maybe a massive protoplanet, possibly as big as Neptune, had smashed into the young gas giant. The impact would have been unimaginably violent, disrupting Jupiter's interior, breaking apart its core, and mixing its materials throughout the planet's depths. If true, this would make Jupiter a cosmic graveyard, a gas giant with the shattered remains of an ancient world buried deep inside. Juno wasn't just exploring a planet. It was unearthing a fossil of solar system history. Even more intriguing was what this meant for planet formation theories. If Jupiter's core could be so messy and irregular, perhaps our models of how gas giants form needed to be rewritten. Maybe planetary collisions were more common than we thought. Maybe the solar system's early days were far more chaotic, worlds colliding, merging, and devouring one another in the darkness. As Juno continued to orbit, it gathered more and more data, each pass confirming that Jupiter's heart was not a fixed structure, but a fluid, dynamic realm, deep, hot, and still in motion after billions of years. Jupiter didn't just form in the beginning. It's still evolving, still reshaping itself. And deep within, it may still hold the echoes of a planet long lost. While Juno's instruments peered into Jupiter's heart, another set of sensors focused upward, toward the skies, where something extraordinary was unfolding. The planet wasn't just a chaotic ball of gas and storms, it was a light show on a planetary scale. Jupiter's auroras, massive glowing rings of energy near the poles, were unlike anything ever seen in the solar system. And Juno was finally close enough to capture them in detail. On Earth, auroras are caused by solar wind, charged particles from the suns slamming into our magnetic field and lighting up the sky near the poles. Scientists had long assumed Jupiter's auroras worked the same way, just bigger and brighter. But Juno discovered that Jupiter plays by its own rules. Jupiter's auroras are hundreds of times more powerful than Earth's and, in some cases, not even related to the Sun at all. Instead, they're generated by internal electrical currents, flowing deep within the planet's magnetosphere. Juno revealed that these auroras pulse in mysterious patterns, sometimes flashing in time with enormous lightning bolts hidden below the cloud tops, sometimes in sync with volcanic activity on its moon Io. That's right. Jupiter's volcanic moon, Io, plays a direct role in powering the planet's light shows. Io is the most volcanically active body in the solar system. Its eruptions eject massive plumes of sulfur and other charged particles into space, where they're trapped by Jupiter's immense magnetic field. These particles spiral along magnetic field lines, crashing into Jupiter's atmosphere at the poles and igniting massive auroral storms, some lasting for days. In infrared, Juno captured what looked like rivers of fire coursing across the poles, moving, shifting, responding to invisible forces. Scientists were stunned. Some of the auroral activity seemed to occur before the events that should have caused them, almost as if Jupiter's magnetic field could predict the energy. Even more bizarre, Juno recorded X-ray flares pulsing from the poles in perfect rhythm, each burst arriving every 11 minutes. This clockwork-like behavior baffled researchers. What could cause such precise timing? The answer remains unclear. Some believe the pulses may be tied to Jupiter's intense rotation, completing one spin every 10 hours. Others suggest unknown processes in the planet's magnetosphere, perhaps driven by interactions with multiple moons. What's certain is this: Jupiter's auroras are not just passive reactions. They are part of a deeply integrated system, a dance of light, magnetism, and gravity unlike anything in the solar system. And Juno, gliding silently overhead, was the only witness to this glowing, electric ballet. It became clear that Jupiter isn't just massive and ancient, it's active, alive, and deeply mysterious. And every orbit, every pass, brought Juno, and us, closer to the secrets hidden behind that glowing veil of light. No journey to Jupiter would be complete without confronting its most iconic and mysterious feature: the Great Red Spot. For centuries, astronomers had stared through telescopes and wondered, what was this enormous, rust-colored blemish swirling across the planet's southern hemisphere? Was it a storm, a scar, a hole, or something stranger? Juno was about to find out. On July 10, 2017, Juno performed one of its most daring maneuvers yet, flying directly over the Great Red Spot at an altitude of just 5,600 miles above the clouds. For 12 minutes, the spacecraft scanned the storm using a suite of high-tech instruments, capturing data in microwave, infrared, ultraviolet, and visible light. What it found would deepen the mystery even further. First, Juno confirmed that the Great Red Spot is truly a storm, a giant anticyclonic vortex, spinning counterclockwise and trapped between two opposing jet streams. It's been raging for at least 350 years, possibly longer. Its diameter is more than twice the size of Earth, though it's slowly been shrinking over the last few decades. But that's just what we see on the surface. Juno's instruments penetrated deep into the belly of the beast, revealing that the Great Red Spot isn't skin deep. The storm reaches an astonishing 200 miles deep into the atmosphere, far below what scientists had imagined. That's 50 to 100 times deeper than Earth's oceans. But here's where things got strange. Inside the storm, Juno detected unusual heat signatures, pockets of rising thermal energy that didn't match surrounding systems. These heat anomalies weren't chaotic, they pulsed in a pattern. Some scientists speculated that the Great Red Spot might be tapping into Jupiter's deeper internal heat, possibly drawing energy from far below the cloud layers. Others considered a bolder idea. The storm might be anchored by some deeper structure, something beneath the visible atmosphere, perhaps part of the fuzzy core Juno had already discovered. Juno also captured stunning imagery: clouds shaped like waves, spirals, and rolls, colored in shades of red, cream, and orange. These complex formations suggested the storm's atmosphere was chemically distinct. One leading theory is that ammonia and sulfur compounds from lower levels are being churned upward, changing color due to sunlight and heat as they reach the upper atmosphere. But why has the storm lasted for centuries when similar systems on Earth collapse after a few days? The answer remains elusive. It may be that Jupiter's lack of a solid surface allows storms to spiral uninterrupted for millennia. Or it could be something deeper, a stable zone of rotation embedded in the planet's structure that sustains the storm like a gyroscope in fluid. Either way, Juno's close encounter made one thing clear: the Great Red Spot is more than just a blemish on a giant planet. It is a window into the most complex weather system in the solar system. And it may hold the key to understanding Jupiter's power, both as a planet and as a force of cosmic history. As Juno continued to dive into Jupiter's atmosphere and orbit its massive poles, the spacecraft began unlocking another layer of the planet's mystery, one that couldn't be seen with cameras or telescopes. This was the invisible realm of magnetism. Jupiter's magnetic field is the strongest of any planet in the solar system, 20,000 times more powerful than Earth's, and it extends outward for millions of kilometers. forming a colossal magnetic bubble called the magnetosphere. This magnetic field doesn't just trap radiation, it shapes space itself. It redirects particles, bends energy, and carves out a region so vast that if it were visible from Earth, it would look larger than the full moon in our sky. But what causes this field? And how stable is it? Juno was equipped with some of the most advanced magnetometers ever launched into space. These instruments measured the strength and direction of Jupiter's magnetic field with astonishing precision, down to 1 part in 10 million. What they found shocked scientists. Jupiter's magnetic field wasn't just strong, it was lopsided. Instead of being neatly aligned around the planet's center, like Earth's relatively symmetrical field, Jupiter's magnetic field was wildly off-center. In one region near the equator, dubbed the Great Blue Spot, the field dipped violently inward, creating a localized anomaly that no existing model could predict. It was like finding a giant magnetic scar carved into the planet's magnetic skeleton. But it didn't end there. Other regions showed signs of unexpected reversals, where the magnetic field flipped direction over short distances. This suggested that Jupiter's internal magnetic engine, its dynamo, was far more chaotic and layered than anyone had imagined. On Earth, the magnetic field is generated by the motion of molten iron in the outer core. But Jupiter doesn't have an iron core. Instead, its dynamo is thought to lie within a shell of metallic hydrogen, a bizarre form of matter created under immense pressure, where hydrogen behaves like a liquid metal. This metallic hydrogen shell spans tens of thousands of kilometers, and it's likely spinning at different speeds in different layers, creating zones of turbulent, rotating energy. These spinning flows twist and distort the magnetic field like a blender filled with charged liquid metal. Juno's data gave the most direct evidence ever of this interior engine. But there was a problem. The magnetic field wasn't stable. Over the course of just a few orbits, Juno detected subtle but measurable changes in the magnetic field structure, evidence that Jupiter's dynamo is evolving in real time. On Earth, such changes take centuries. On Jupiter, they might happen in months or years. This raises incredible questions. Is Jupiter's magnetic field slowly flipping like Earth's does every few 100,000 years? Or is it undergoing something more extreme, a kind of internal reformation driven by unknown processes? One thing is certain, Jupiter is not a static world. It is dynamic, volatile, and alive at its core, with energy flows and magnetic forces that are still shaping its evolution today. And Juno, with each pass, is capturing these changes as they unfold, giving humanity its first magnetic map of a giant. Since arriving in 2016, Juno has rewritten textbooks, shattered theories, and shown us that even the biggest planets are full of secrets. And it's not done. NASA has extended the mission to September 2025, allowing Juno to explore Jupiter's moons, ring systems, and even make flybys of volcanic Io, frozen Europa, and chaotic Ganymede. What started as a 5-year dive into a gas giant has become a long-term mission of discovery. And through Juno's eyes, we've seen a world that is beautiful, violent, ancient, and possibly unique in the universe. Jupiter has protected Earth from countless asteroid impacts. It may have shaped the entire architecture of the solar system. And now, with Juno, we're beginning to understand its true role. It's not just a planet. It's a cosmic guardian. A record of the past. A warning for the future. And maybe, just maybe, a sign that the universe still holds wonders we haven't even begun to imagine. If you enjoyed this journey, don't forget to like, subscribe, and comment below. What do you think Juno will discover next? Could Jupiter hold the key to how planets, and life, really begin? This is Mysterious Universe. And the deeper we go, the stranger it gets.